Hello friends, today we solve problem on uniform acceleration motion. So let's start. Problem on uniform acceleration motion or motion under gravity. Here is a problem. A stone is thrown vertically up from the top of the tower which is 40 meter high with the velocity 20 meter per second. 3 seconds later, another stone is thrown vertically up from the ground with the velocity of 30 meter per second. Calculate when and where two stones will meet from foot of the tower. Okay. Before start the solution, let's remember or consider some sign convention. Okay. In our previous question, we consider sign convention for the acceleration or for the motion under the gravity. Okay. Where if particles moves against the gravity, we consider negative value of g. If particles falls under the gravity, we consider positive value of g. Okay. In Newton's motion equation, S is the displacement of the particle. Okay. So displacement depends only on initial and final position. Okay, the displacement depends on only initial and final position of the particle, and also displacement is a vector quantity, means displacement has magnitude as well as direction. So displacement have direction. If direction involves, we have to consider sign convention. So what are the sign convention? If the particle moving in a vertical path, say A, particle A or body A moving in a vertical path, the distance or displacement of particle is above the initial position, then we consider positive value of displacement. Okay. If particles move downward from its initial position, then we have to consider negative value of displacement. This is a very important point. Displacement is a vector quantity, means it has magnitude and direction. If direction involves, we have to consider sign convention. If particles moves in a vertical path and the initial position particle is A or position 1, if the particles moves in upward direction from the initial position, we have to consider positive displacement. If the particles moves in a downward direction, we have to consider negative displacement. Positive y, negative y. Okay, it's a very important point. This point we use in this problem. Okay, so here in problem they have to calculate when and where two stones will meet from the foot of the tower. So in this problem there are two bodies, stone A and stone B. So first draw the diagram. So this is a tower, and tower has height 40 meter. A stone is thrown vertically up from the top of the tower, means there is a stone B thrown vertically up with initial velocity UB has value 20 meter per second. There is another stone which is at bottom, thrown vertically up from the ground, which is at bottom with initial velocity 30 meter per second UA. We have to calculate when and where two stones will meet from the foot of the tower. So the motion of stone B is going upward up to when his acceleration becomes 0, means the final velocity of stone B becomes 0 and reach at the maximum height. When stone B reaches the maximum height, then he start to fall under the gravity and start motion in downward direction. For stone A is thrown vertically upward. His motion is against the gravity, and some particular point both stone A and stone B meet each other. We have to calculate that distance and time where they meet each other. Okay. In this question there are two bodies, stone A and stone B. So we have to consider origin first, and they asked to calculate the distance from the foot of the tower. So we consider this foot as the origin. Okay, this foot as a origin. Okay, let's consider point C will be the any point in between them where both the stone meets each other. Okay, let y be the distance of stone A or displacement of stone A up to point C. Okay, then remaining distance will be 40 minus y. Okay, so let's start with the solution. Now first consider motion of stone B. Motion of stone B. The motion of stone B is a motion under the gravity. This is a MUG. Okay, the motion under the gravity. Okay, the motion from, let's consider motion from B to C. Let's consider motion from B to C. Okay, when we project or we throw a ball in a vertical direction, it achieves some particular height h, then it falls under the gravity. So from point B to point C, first from point B to D, it is a motion against the gravity. Then from D to C is a motion under the gravity. Here is a confusion. What sign convention we should take? Okay, from B to D is a motion against the gravity. D to C is a motion under the gravity. But we have to consider sign convention at the initial. Okay, we take the motion from B to C, means complete motion from B to C. Okay, from B to C, initially particle as a point B or stone at a point B. At a point B, a stone is thrown vertically up. We have to consider sign convention at the initially. So initially stone is thrown vertically up, means against the gravity. So here we have to consider negative sign convention for, okay, the initial velocity of B is given 20 meter per second. Okay, final velocity of B not required. Okay, second, acceleration of B. Acceleration of B is 9.81 meter per second, but negative. Okay, initially stone is thrown vertically up. So we have to consider the sign convention at initially. Okay, next, time required for stone B to reach at position C is T1 seconds. Okay, now displacement of stone B. Okay, the position stone B is here. Okay, initially we consider sign convention if the displacement covered by the stone B in upward direction we consider as a positive, and displacement of the stone in below the initial position we consider as a negative. And displacement is a vector. Displacement is depend on initial and final position. The initial position of stone B is at a point B and final position of stone B as a point C. So we have to consider this displacement. Okay, and this displacement value is this displacement value is 40 minus y. Okay, and this displacement is below the initial position of the B, so we have to consider negative value of 40 minus y meter. Okay, so here we consider two sign convention. One is for the displacement and second is for the acceleration. So for acceleration we have to consider initially the B is projected in upward, then reach at a point D and then at point D to C it is a motion under gravity. So here though two motion is, one is a motion against the gravity and another is a motion under the gravity. So we have to consider sign convention at a initially it is a motion against the gravity, therefore we have to consider negative value of A. Then the displacement, for the displacement depends on initial and final position. The initial position of stone B is at a B and final position of the stone B is at a C. So the displacement covered by the stone A above the initial position we have to consider positive. The displacement which are covered in below the initial position we consider as a negative, and this displacement is 40 minus y and the value is negative. So next, using Newton's motion equation. Okay, so Newton motion equation, S is equal to ut plus half at square. Okay, so here it is for stone B, so SB, UB, TB, AB or TB. Okay, the displacement of stone B is minus 40 minus y. Initial velocity of stone B is given 20 meter per second. Time required for the stone B is t1 seconds. Okay, plus half into acceleration of stone B is minus 9.81. Okay, and time required for the stone B is t1 seconds. Okay, so we get the first equation here. Okay, let's talk about motion of stone B. Motion of stone A. It is a motion under gravity and it is against the gravity, we have to consider negative. So motion from A to C. Okay, initial velocity of stone A we know UA is equal to 30 meter per second. Initial velocity of stone A is 30 meter per second. Final velocity of A not required. Then time required for the A. Since in the question they mention after 3 seconds stone A is thrown, means if stone B is in motion for t1 second, then stone A will be in motion for t1 minus 3 seconds. Now acceleration of A. From position A to position C, it is a motion against the gravity. So if the motion against the gravity, we have to consider negative value of G. Okay, and the last part is the displacement of A. Here the displacement of stone A, initial position of stone A is at a position A and it is above the initial position, therefore we consider this displacement is equal to positive y. Okay, so we get the initial velocity of stone A is 30 meter per second, final velocity of A not required, time required for the motion is t1 minus 3 seconds. Okay, acceleration of stone A is minus 9.881 meter per second square, and the displacement of A is positive y meter. Okay, so according to Newton motion equation, S is equal to ut plus half at square. Here SA, UA, TA, AA and TA. Okay, so SA, displacement of stone A, is positive y. Initial velocity of A is 30 meter per second. Time required for the motion is t1 minus 3 seconds plus half into acceleration is minus 9.81 and t1 minus 32 seconds. We get equation number 2. Okay, so substitute value of y in equation 1. Okay, so what is the equation 1? Equation 1 is minus 40 minus y is equal to 20 t1 plus half minus 9.81 t1 square. Okay, we substitute the value of y in equation 1. So minus 40 minus in bracket 30 t1 minus 3 minus 4905 t1 minus 3 square, okay, is equal to 20 t1 plus minus 4.905 t1. Okay, if we solve this equation, we get the value of t, and t is equal to 4.416 seconds. Okay, so we get first unknown value. The first unknown value they have to calculate when the two stone will meet from the foot of the tower. Then the answer is t is equal to 4.41 second. We also have to calculate where two stone will meet from the foot of the tower, means we have to calculate value of y. So substitute value of t in equation number 1. Okay, so what is the equation number 1 or equation number 2? So substitute the value of t in equation number 2. So y is equal to 34.416 minus 3 minus 4.905 into 4.416 minus 3 square. Okay, and we get the value of y is equal to 32.64. This is our final answers. Okay, so here in question they have to calculate when and where two stone will meet from the foot of the tower. Then the time is 4.416 seconds, and the distance from the foot of the tower is 32.64 meters. Okay, thank you. If you find my videos are helpful, then please like, share and subscribe our channel. Thank you.